In this video, I am going to explain the concept of stack using arrays in C programming language. So let's start with stack. Look at the diagram at the right hand side first. Suppose this is a container and it has an open end. That is, the top of the container is open. The container is segmented and each segment is marked as 0, 1, 2, 3 and 4. So we can say that this container has 5 segments counting from 0 to 4. And let's give the name of this container as stack. And since stack has 5 segments, so we can say that the size of the stack is 5. Now within this stack we are going to place this block numbered as 10, 20, 30, 40 and 50 one by one. Here we are going to place or insert this block into the stack from this open end. And if we want to take out this block from this container stack, then we have to do the operation from the top only, that is from the open end only. So all insertion and deletion will take place from the top of the stack. Now to point out the top position, we require a top pointer. Look, the red arrow is marked as top. So this top pointer will point to the top position of the stack. Initially there is nothing inside, that means the stack is empty. And for that I place this top pointer outside the stack. You can also think that the top is pointing to -1, which is one step back to 0. Now suppose I want to insert block marked as 10 into the stack. So for that, top has to be incremented to its next position, that is top will point to the first segment of the stack, that is 0. And the 10 will be inserted in stack top, that is at stack of 0. So look at the operation very carefully. Suppose I want to insert the block 10 within the stack. For that we need to increment the top to the segment 0. That means top is pointing to the stack 0 position. Now within stack 0 position we are inserting this 10. In other words, we can say that the block 10 is at the top of the stack. Now suppose I want to insert block 20 within the stack. For that we need to increment the top pointer to the next segment, that is 1. That means top is a pointer which is pointing to the top of the stack where the data is going to be inserted. At present, since top is pointing to the location 1, so 20 will be inserted at stack top, or you can say at stack 1 position. Next, let's insert the block 30. So we have to increment the top pointer to the 2 position of the stack. Now 30 will be inserted within that position. Next, top is incremented to 3, so 40 will be inserted at stack 3. And at last, stack is pointing to the last position of the stack, or you can say the maximum position of the stack. And 50 will be inserted over here. Look, top is pointing to the top element of the stack. Or in other words, you can say the last element which is inserted is the top element. Now look, no more positions are available within the stack. That means the stack is full. So when the top pointer reaches to the size -1, the size of the stack is 5. So 5 minus 1 means 4. Since the segment of the stack is counting from 0, so the maximum size will be size -1. Here in this example, it is 4. So when top is pointing to size -1 of any stack, we can say that the stack is full, so no more addition will be take place. At this point of time, insertion will stop. Now I will show you the deletion process from a stack. In a stack operation, the last element will be come out first. In other words, we can say that last in, first out. So look at the operation. So 50 will come out from the stack and the top will be decremented by 1. That means it will again come down to 3 position of the stack. So 50 is the topmost element which has been deleted. So during deletion, you do not have to specify which element is to be deleted from stack. The last in first out operation will take place. The last element or the element which is pointed by the top pointer will be deleted. Now look at this instance. Top is pointing to the position 3. And within this 3 position, 40 is there. So when we are going to delete an element from the stack, 40 will be deleted because it is pointed by top now. So 40 will be deleted, top will again decremented to its previous position, that is 2. Next 30. Next 20. And at last, when 10 is deleted, top will again return back to its initial position, that is -1. At this point of time, we can say that stack is empty. So whenever top is pointing to -1, we can say that the stack is empty. Now let me summarize the whole operation. Stack data structure referred to the list stored and accessed in a special way, where last in first out, in short it is called LIFO technique, is followed. So remember the operation. Whenever there is an insertion, top will be incremented first. It will point to a certain position within the stack and the element will be inserted at that position only. So at every insertion, top will be incremented and finally it will reaches to the maximum size. So when it reaches to the maximum size, the stack is full. You cannot add any more data within this stack. Now, during the deletion, remember it's a last in first out operation. So the last element which is inserted within the stack will be come out first. For successive deletion, top will keep on decrementing and when it reaches to -1, that's mean the stack is empty. So the stack has two operations. In stack, insertion, which is called push, and deletion, which is called pop, take place only at one end, called the top.
Let's demonstrate a practical example of stack. So this is a stack. This is a stack for disk. We can insert any type of disk, CD, DVD, etc. So this is a stack. In this stack, I'm going to insert this disk numbered as 1, 2, 3, 4, and 5. Let's insert the number 1 disk into the stack. So this is the first element of the disk I'm inserting into the stack. At present, disk 1 is the top element. Next, let's insert disk 2. Then disk 3, then disk 4, then disk 5. At present, disk 5 is the top element in the stack. In this situation, we cannot access any other disk until and unless we are taking out the topmost disk, that is disk 5. So during deleting an item from a stack, we need to pull out the topmost disk first. So this is the last element that has been inserted. So the last in should be pull out first. That's why stack is called last in first out data structure. So the last in disk is the first out in the deletion operation. Then disk 4, then disk 3, then disk 2, then disk 1. Now the stack is empty. So this is what you called stack of CD, and it is an example of stack. And by inserting and removing the disk, you can understand the stack operation.
Now let me write down the operation of push and pop in a step-by-step manner, which will finally form an algorithm. Look how this concept can be converted to an algorithm. When we are going to implement the concept of stack using C programming language, we require an array to represent the stack. So this stack is nothing but an array. Next, we require the size. This is the maximum size of the array, or you can say the size of the stack. Then top, it points the upper or top position of the stack, initially set to -1. So in the diagram, I've already shown you the top is initially pointed to -1. For every insertion, top will be incremented, and for every deletion, top will be decremented. But the initial position of the top should be kept in -1 position. And at last, we require a data that is going to be inserted within the stack. So these are the variables of the structure required to build the algorithm. Since there are two operations, push and pop, that is insertion and deletion respectively. So let me show you the push operation of stack first. So let's start with algorithm to push an element into stack. Now the first point is that check for stack overflow. That's mean before inserting any element, we will first check that whether the stack is full or not. So how to check whether a stack is full or not? We have to check the top pointer. If it is reaches to the size -1 position, that's mean if top is equal to size -1, then print stack overflow and return to the main program. Otherwise, we have to go to the step 2. So in step 2, if the stack has some empty room, that is stack is not full, for that we have to run the step 2. We need to increment the top pointer by 1, that is top equal to top plus 1. So whatever the current position of top, it will be incremented by 1. Then perform the insertion. That is, the data is to be stored within the stack top position. This data will be taken from the user input and that will be stored within stack top position. Or in other way, you can say that data will be stored within stack where the top is pointing, and at last return to the main code. Now next come to the algorithm to pop an element from the stack. So before deleting an element from a stack, we need to check whether the stack has some element or not. Or you can say check for stack underflow. If top is pointing to -1, that is if top is equal to -1, then print stack empty. Think about the initial position of the stack. When top is pointing to -1, that means nothing is inside the stack. That means the stack is empty. And if it is not empty, then we have to go to the step 2. And within the step 2, store the top element into a variable, data equal to stack top. That means we are keeping a backup of the top element within the data variable. This step is optional. Next, after backing up the top element within the data variable, we need to delete the top element. That means delete the top element by decrementing the top element by 1. So when the top pointer is decremented by 1, the previous element will be assumed to be deleted. Now next, return the deleted element, which is backup within the data variable, to the main code for display. Now by looking into this algorithm, we are going to implement this concept of stack by using C programming language. I will suggest you to write the algorithm in your copy. So by looking into that algorithm, we are going to design or implement stack using C programming language. Let's start writing the C program. File, create a new file. First of all, include stdio.h. This is the header file for input output. Next, suppose stack is the array with size element. Let me define this size as a 5. So this is a preprocessor directive and 5 is initialized within size. So when we declare stack size, that means stack is of size 5. Next, we require a top variable and it is initialized with -1. Then the data. Now first of all, let me write down the prototype of the function that we are going to use within this program. The first one is the void push. So during push, it requires an integer data, and during deletion, or you can say during pop, it will accept nothing, but it will return the deleted data, which is an integer type. There will be another operation, that is the display of the stack. So within this function, we will display the content of the stack. So these three are the prototype of the function that are going to be used in the program. Now let's start the push function. So void push. So it will accept a data from the main, and there it will check first whether top is pointing to size -1 or not. If so, then it will print overflow and return to the main code. Now, if the top is not equal to size -1, then top will be incremented by 1, so top ++. And within the stack top, we will store the data given by the user. So look at the algorithm of push operation and check how I have implemented it in C programming language. Now the pop operation. So during pop, it requires no argument. Pop means deleting element from the stack. So before deletion, we need to check whether the stack is empty or not. So for that, we have to write whether top is equal to -1 or not. If it is equal to -1, that means the stack is underflow, or you can say empty. Since the pop function returns an integer, and in the case of underflow, nothing to delete, for that we need to return some arbitrary value, say -9999. So -9999 represent nothing has been returned from the pop function. Now If the top is not equal to -1, that means top is pointing to some location within the stack. That means something is inside the stack. For that, we require a backup of the top element of the stack. And that's why I have written data equal to stack top. The top element of that stack will be backup within the data variable. Now reduce the top pointer by 1, that is top minus minus, and return the backup data which is stored within the data variable. Now let's write the display method. So this display method will display the content of the stack. For that we require a loop. So I is the loop variable. So stack starts from 0 index, so I have written I equal to 0, and the last element of the stack is pointed by the top variable or the top pointer. So I less than equal to top, I plus plus. Let's write this comment line. Print stack is as follows before the loop. Then within the loop, let's print stack of I. So this loop will print stack of I, that is I runs from 0 to top. That means display function will print all the elements from stack 0 to stack top, because the stack elements are residing within the 0 and the top position. Now come to the void main function. From within the void main function, we will call the push, pop and display all these function. So look what happened. Let's call the push function first with the value 10. Now display the stack by calling the display function. Next again call push with 20, then push with 30, then 40, then 50. Finally again call the display function to display the stack. Let's run the program. Look at the output. So when we push the element 10, so after that I display the stack by calling the display function. So it is printing stack is as follows 10. So after entering 20, 30, 40 and 50, again I have called the display function. So look, after 10, 20 has been inserted, then 30, then 40, then 50. You can think like that. 10 is in the 0 index or in the 0 position. 20 is in the 1 position, 30 is in the 2 position, 40 is in the 3 position and 50 is in the 4 position. At present, top is pointing to 50, that is at the 4 position. Now, if I try to push another value, say 60 within the stack, look what happened. It display overflow. Since the size of the stack is 5, look, the size of the stack is 5. So we cannot enter more than 5 elements within the stack. And for that, it is showing overflow in the output. Already there are 5 elements are present within the stack. So when we are trying to enter another value 60 at this point of time, so within the push function, look at the push function, top is pointing to size -1 at present, and for that it is displaying overflow and return to the main code. Now let me show you the deletion operation. First of all, within the main method, let me write like this: deleted element equal to %d. So it will be pop. That's all. So whenever we call the pop function, it will call the corresponding pop function and find out the top element. It will delete the top element and that will be returned to the main method. So the deleted element will be come over here and displayed over here. So deleted element will be the element which was pointed by top. And after a deletion, we need to check the status of the stack. So for that we have to call the display function. Let's run the program. Look what comes out in the output. Look at the output. After inserting all these values 10, 20, 30, 40 and 50, top is pointing to the final position or the top position, that is at 50. So whenever we call a pop function, we do not have to tell which element is going to be deleted. The last element will be deleted first, that is the stack follows last in first out operation. So the last in is the 50, so that will be come out first. So the deleted element is 50. After deletion of 50, top will be decremented to the previous index, and when we display the stack, it will display 10, 20, 30 and 40. Since 50 has been deleted from the stack, so it will show the remaining 4 elements, that is from 10 to 40. Now look, if I delete the rest of the 4 element and call the display function, look what happened. Look at the output. After deletion of 50, the stack becomes 10, 20, 30 and 40. After calling pop function 4 times, all the elements are deleted from the stack, so the stack becomes empty. Now at this point of time, if I want to delete another value, so what will happen? Look, it is showing underflow. So after deleting all the elements, nothing is inside the stack. So again, when we are going to delete another element by calling pop function, it is showing underflow because nothing to delete. Top is pointing to -1 position. That's why it is showing underflow. And it is returning deleted element -9999. That's mean nothing. I have written -9999 if top is pointing to -1. So this is nothing but an arbitrary value. Because pop function returns some integer value, we need to return some integer value whether the condition satisfy or not. So this is the complete program of stack with size 5. If you have any query regarding this, write it down in the comment box. I will try to reply you back as soon as possible. Thank you.